Hello class, hello students. This is my first class for rational numbers, class 8. So we'll be starting with the very first chapter, that is rational numbers. And I hope we all are following the books Mathematics Today by O.P. Malhotra and S.K. Gupta. So to start with this chapter, we'll start with rational numbers. Before we start with rational numbers, we need to know what are natural numbers, whole numbers and integers. This you all must have learnt in the previous classes. We know that natural numbers are known as counting numbers which start from 1, 2, 3, 4 and so on. We start from 1 and they continue, right? They are never ending numbers. Then it is whole numbers. What is whole numbers? When 0 is added to the set of natural numbers, they are known as whole numbers. They start from 0 and then they continue 3, 4, 2, 3, 4, 5 and so on. Now what are integers? Integers are all the negative numbers, all the positive numbers as well as 0. All the three types of numbers, negative, positive and 0, they make a set of integers. It is represented by I or Z. From minus infinite to minus 3, minus 2, minus 1, 0, 1, 2, 3 up to infinite. Means from minus infinite to plus infinite, all the numbers that come are in the set of integers. Then our main topic is rational numbers. So what is rational numbers? Any number which is written in the form of P upon Q, or to make it easy, any number which is written in the form of numerator upon denominator, where P and Q are integers. Means P can be negative or positive any number, Q can be negative or positive on any number, but the condition is that Q will not be equal to 0. Means the denominator can never be equal to 0, because in mathematics division by 0 is not defined. That is why. Means what are rational numbers? Simply rational numbers are written in the form of numerator upon denominator. Then denominator should not be equal to 0. That's all. Now let us take few examples based on rational numbers. Suppose I say 5. So 5 is a rational number because we can write it as 5 upon 1, where 5 is an integer, 1 is an integer, and you can see that denominator is not equal to 0. Next we can consider minus 11. That is also a rational number because it can be written as minus 11 upon 1, where minus 11 is an integer and 1 is also an integer. Let's think about 0. What can you say about 0? So 0 is also a rational number because at least we can say 0 can be written as 0 upon 1, where though the numerator is 0 but denominator is not 0. So it is a rational number because we know that anything which is written in the form of numerator upon denominator, but condition is denominator should not be equal to 0. So here we see that denominator is not equal to 0. So this is also a rational number. So I am writing this sign stands for belongs to and Q stands for rational number. So all these numbers are rational numbers. But if I say 5 upon 0, so this is not a rational number because in this we can see that denominator is 0. I hope by now it would have been clear to you that what is a rational number. Now our next point is what is positive rational number and negative rational number. Rational numbers can be written as positive and negative both. So very simple, if in a rational number both numerator and denominator have the same sign, means it can be positive, both can be positive or both can be negative, then they will be positive. Suppose I have taken an example 8 upon 11, where 8 is positive and 11 is positive. So finally it will be positive rational number. Then I have taken minus 8 upon minus 11, though they are in fraction form, so minus and minus will cancel itself and finally you will get 8 upon 11, so that is also positive. But if any one of them, any one of P or Q is negative, then the numbers, the rational numbers will be negative rational numbers. In first example, I have taken minus 8 upon 11. So finally the minus, this rational number will carry minus sign. Or in the second, I have taken 8 upon minus 11. So in this case also, minus will be carried with this rational number. So in this case, both of them will be negative. So one thing you need to learn, that if both the signs of numerator and denominator are positive or negative, it will be a positive rational number. If the signs are different, maybe in the numerator or denominator, if the signs are different, then they will be negative rational number. Next topic is equivalent rational numbers. What is the meaning of equivalent rational numbers? Let's take an example. 1 upon 2. You can say that this is equal to 2 upon 4, or you can say it is equal to 5 upon 10, or it can be equal to 20 upon 40. I hope you can make out the difference. The difference is, if there is a rational number P upon Q and both numerator and denominator are multiplied by a common integer. It can be negative, it can be positive, by a common integer except 0. Q cannot be equal to 0. So if any rational number that is written in the form of P upon Q is multiplied by a common number, then by a common positive integer, you can say by a common positive integer, or just take it as a number, it by a common number, then whatever fraction you get, new fraction, that and the previous one are equivalent. Means this will be Pn upon Qn. P into n is Pn, Q into n is Qn, and finally what will happen? N and n will cancel, and again you will get back as P upon Q. Again you will get back as P upon Q. Now if you can see at the example, this is 1 upon 2, this 2 upon 4 can be cancelled, 2 1s are 2, 2 2s are 4, it comes out to be 1 upon 2. 5 upon 10, 5 1s are 5, 5 2s are 10, 1 upon 2, 0 and 0 cancel, 2 upon 4, finally you will get 1 upon 2. So these are known as equivalent rational numbers. Next topic is rational number on a number line. Means how to represent rational numbers on number line. Rational numbers on number line. Let's take an example. I will be discussing it with the help of an example. Let's take represent 4 upon 5. Represent 4 upon 5 and minus 13 upon 4 on number line. Question. I will be explaining this with the help of a question. I have taken two different numbers. One is 4 upon 5 and one is minus 13 upon 4. We have to represent both these numbers on a number line. Very first thing what we are going to do, we will draw a number line. We will draw a line. Let it be named as X and X dash. Anywhere on this, generally in the middle, we take a point 0 and represent it by O. This is the O. This is 0. Anywhere on the line, just take a point O, that is, name it as O, and that will be a 0 point. Now 4 upon 5 means that 4 is divided into 5 equal parts. I am talking about 4 upon 5. 4 upon 5 means that 4 is being divided into 5 equal parts. Anywhere, since it is positive, so you know that on the right hand side it is all positive numbers, and on the left hand side it is all negative numbers. So what we will do, 4 upon 5. 4 upon 5 means that 4 is divided into 5 equal parts. So we will take any unit. Let us take it as A. OA. OA is equal to 1 unit. 1 unit. and then divide it into 5 equal parts. 5 equal parts. Let's take first part, second part, third, fourth, and fifth. Now I have divided them into 5 equal parts. I have divided them into 5 equal parts. 1, 2, 3, 4, 5. Let us name it as P, Q, R, S, and A. Means OP will be 1 upon 5. I am just rubbing it out. 1 unit. OP will be 1 upon 5. OQ will be 2 upon 5. 2 upon 5. OR will be 3 upon 5. OS will be 4 upon 5. And OA will be 5 upon 5. And 5 upon 5 is 1. You need to represent what? 4 upon 5. That is, S point is representing 4 upon 5. So simply we can say that OS is equal to 4 upon 5 on number line. Now, next I am taking as minus 13 upon 4. So you can see that this can be converted, minus 13 upon 4 can be converted into a mixed fraction. So I am writing it here. Minus 13 upon 4 can be written as 4 3s are 12, 10 point, or you can say 3 whole 1 upon 4. I am writing it like this. I am not writing it in decimals, but I am writing it as mixed fraction, that is minus 3 1 upon 4. So you know that minus 3 will be lying to the left of the 0 point or left of the O point. So I am taking, let this be 1 unit, 2 unit, and let this be 3 units, and let this be 4 units. A dash, B dash, C dash, and D dash. Now what is required? Minus 3 whole 1 upon 4 means from 0 you will move minus 3 points. 1 minus, then second minus, and then third minus. Now when you have already crossed minus 3, this we have already traveled. Now what is left? 1 upon 4 means the other part, that is C dash and D dash, has to be divided into 4 equal parts, and we need one part of those 4 equal parts. So I am dividing it into 1 part, 2, 3, and 4 parts. Now this is 1 upon 4, this is 2 upon 4, this is 3 upon 4, and this is 1 upon 4. So we need minus 3 and 1 upon 4. This point is, let us name it as M. M. So from O to M represents minus 3, 1 upon 4. So I will be writing OM is equal to minus 3, 1 upon 4, or minus 13 upon 4 on number line. Next topic is density property of rational numbers. What is the meaning of density? Density means that, okay, let us take an example. Suppose I have taken a number line x dash and x, and I have marked 2 points in between them, 1 and 2, and I ask you how many numbers can come in between 1 and 2. Some of you may say 1, 200, 200, 1000, lakhs or whatever. But in fact, there are infinite numbers in between any two given numbers, or between any two rational numbers. There are infinite types of infinite numbers. Example, suppose I say that 1.5. So you know that 1.5 will lie somewhere in between 1 and 2, because 2 plus 1, 3, 3 upon 2 is 1.5. Or if I can divide 1, 2, I can divide this line segment 1 and 2 in two parts. So that will be, one number is this, other is this, and then it is this. So what we did, we have moved one number in between 1 and 2. Now these 2 points, let us take it as A and B. So C is a number which lies between 1 and 2. Again we can take a number which lies between A and C. Let us take it as D. Again we can take a number which lies between C and B. That let us take it as E. In the same way, we can take a number which lies between X dash and A. In the same way, we can take a number between A and D, somewhere here. Same way, D and C, somewhere over here. C and E, somewhere over here. So, like this. Again, we have few small segments made. Again, in between them, we have few numbers. And again, we'll keep on continuing and continuing. So, finally, we came to a result that there are infinite numbers that can be inserted or that are already present between two given rational numbers, and that is known as density property of rational numbers. Now the next topic is comparison of rational numbers. So what is the meaning of comparison? Suppose I take an example. For example, let's take minus 3 upon 8 and 7 upon minus 12. We have to compare them. Comparison means whether one number will be greater than the other one, or one number will be less than the other one, or both these numbers will be equal. Let's see what are they. So in order to compare any two rational numbers, first of all we check whether the denominators are equal. If they are not equal, then we take the LCM of the denominator. Suppose I would have written minus 3 upon 7 and 5 upon 7. Now in this case you can see that the numbers, the denominators of these numbers are equal. So you can easily make out that minus 3 is less and 5 is greater. So you would have said that it is minus 3 upon 7 is less than 5 upon 7. But in this case, I have taken two different numbers with different denominators. One is 8, other one is 12, because it is 7 upon minus 12, and just now we have learnt that minus 3 upon 8 and 7 upon minus 12 can be written as 7 upon 12. So in any case, 8 and 12 are the denominator. We will take the LCM of 8 and 12. So LCM of 8 and 12. 8, 12, 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6, 2 1s are 2, 3 and 3, 1 comma 1, 2 to the 4 to the 8 is 24. So LCM comes out to be 24. I hope you are familiar with the word LCM and how to find it out. So I'm not doing too much on this LCM. So we get LCM of 8 and 12 is 24. Now this 3 minus 3 upon 8 and 7 upon minus 12 will be converted into a number with LCM 24. So in order to do 3 upon 8, 8 3 is 24, so we'll multiply by 3, so that is minus 9 upon 24, and similarly 7 upon minus 12, or you can say minus 7 upon 12 into 2 into 2, that is minus 14 upon 24. So you can easily make out which number is bigger. I hope minus 9 is bigger and minus 14 is smaller. So you can say that minus 9 upon 24 is greater than minus 14 upon 24, but implies that, or you have to write it in the form of the original question, so that can be written as minus 3 upon 8 is greater than 7 upon minus 12. That's it. Next topic is absolute value of a rational number, and I hope this is the last topic of your first exercise. So what is the meaning of absolute value? In the previous classes you must have studied that mod of a is a, or even mod of minus a is a. What is the meaning of mod? By this time you should know this much, that whatever comes inside mod is always positive. Suppose I take 11 upon 24 and its mod, means it can be written as mod of 11 upon mod of 24. So finally it will be 11 upon 24. Now I take minus 11 upon 24 in mods, that will be minus 11 mod upon 24 mod, and that will be 11 upon 24. Again I will take 11 upon minus 24 mod, so that is 11 mod upon 24 minus 24 mod, that gives you 11 upon 24. So very basic thing you need to remember, that whatever is inside the mod, when you remove the mod, it will